Dr. R. Hemavati is an assistant professor in mathematics in Queen Mary's, Chennai. She has specialized on functional analysis. Having 12 years of experience in teaching, she has won various awards for her performance. She has published papers in 14 international journals, 3 national journals, and has presented papers in 10 international and in 5 national conferences. She is also one of the editors for an international journal.
Welcome to UGC lecture series. In this subject Statistical Methods 2, and in this session 3, we are going to study about independence and association of attributes. So, the objective of this session is to study about the independence and association of attributes. In the earlier sessions, we have studied about the attributes basics, and we started with the consistency of data, the criterion for the consistency of the data of attributes, also definition of independence and the criterion for independence of attributes have been studied in the earlier sessions. So, going ahead, and in this present session we are going to study about the independence and association of attributes. We will work out a problem in independence and discuss about association of attributes. To go further with the independence, we need these notations AB naught and delta. Let us write AB naught is equal to bracket A into bracket B divided by n. Bracket A stands for the class frequency of the persons having the attribute possessing the attribute A, and bracket B represent the class frequency of the attribute B. And capital N is the total number of members in the population, which is the value of AB under the hypothesis that the attributes and A and B are taken to be independent. And then we will write delta. What is delta? Delta is equal to AB minus AB naught. That is, the excess of AB naught over AB is represented as delta. So, we have discussed in the previous slide what does AB naught stands for. AB naught stands for bracket A into bracket B by n. Therefore, we have delta is equal to AB minus A into B divided by n. So, simplifying further, delta is equal to taking that 1 by n outside, n into AB minus A into B. Okay. What does n stands for? N stands for the total population. So, n can be written as AB plus A beta plus alpha B plus alpha beta into AB minus you have A. A is written as AB plus A beta, and B is written as alpha B plus AB. Okay. We will multiply and simplify this. So, this goes as 1 by n. AB into AB is AB square plus A beta into AB plus alpha B into AB plus alpha beta into AB. Okay, minus simplifying this. Simplifying this, we have AB, all these are within brackets, right, representing the class frequency. Okay. So, AB into alpha b plus AB square plus A beta into alpha b plus A beta into AB. What are the terms which can be cancelled? You have AB square getting cancelled, and A beta and AB gets cancelled, alpha b into AB, alpha b into AB also gets cancelled, and you have alpha beta into AB, and this is A beta into alpha b. So, 1 by n alpha beta into AB minus A beta into alpha b. This is another simplified form of delta, or it is called a formula for delta. Actually, delta is excess of AB naught over AB. Delta is equal to AB minus AB naught, and another formula for delta is 1 by n alpha beta into AB minus A beta into alpha b. Okay. Proceeding further, we will go ahead with an example solving this. If delta is equal to AB minus AB naught, then with the usual notations prove that A bracket A minus alpha into B minus beta plus 2n delta is equal to AB square plus alpha beta square minus A beta square minus alpha b square. And then we also have to prove delta is represented as B into beta by n, AB by B minus A beta by beta, and this is equal to also written as A into alpha by n, AB by A minus alpha B by alpha. We will go ahead with the solution taking the left hand side. What is the LHS of 1? LHS of 1 is A minus alpha into B minus beta. This is what is LHS of 1 plus 2n delta. Okay, we will simplify this. What does A stands for? A stands for AB plus A beta. Okay, minus what does alpha stands for? Alpha stands for alpha b plus alpha beta. Okay, this into you have B. B is written as A B plus alpha b minus beta is written as A beta plus alpha beta. That is bracket A is written as AB plus A beta. How is that? What is another attribute corresponding to A? Another attribute is B. Therefore, it is written as AB plus A beta. Beta, B and beta are complement to each other. So, A is written fixed. So, AB plus A beta minus you have alpha. So, that is another attribute corresponding to alpha is B and beta. Therefore, it is written as alpha B plus alpha beta. Similarly, B is written as AB plus alpha beta. Corresponding to the attribute B, the another attribute is A and its complement is alpha. Therefore, B is written as AB plus alpha B minus beta. So, similarly talking about the another attribute corresponding to beta is A and alpha. Therefore, A beta plus alpha beta. Now, continuing with this expression 2 into what is n? N stands for the whole thing, right? I will write n first as it is and then we will expand delta. We will write the formula for delta. Delta formula we just arrived in the previous slides. Delta is equal to 1 by n into alpha beta into AB minus A beta into alpha b. This I am going to write it here. What is it? Alpha beta into AB minus A beta into alpha b divided by n. This is from the formula for delta. Okay. So, n gets cancelled, and organizing these things, we can write this as AB minus alpha beta plus you have A beta minus alpha b. Right? This is first one organized into similarly writing this A b minus alpha beta, that is these two, minus of A beta minus alpha b. Okay, plus this 2 into alpha beta into AB minus A beta into alpha b. Okay, and this is in the form of x plus y into x minus y, right? This is x and these two are y. So, x plus y into x minus y is x square minus y square. So, using the formula you have AB minus alpha beta whole square plus A beta minus alpha b whole square, x square minus y square plus 2 into alpha beta into AB minus A beta into alpha b. Expanding this using A minus b whole square. A minus b whole square is A square plus b square minus 2ab. So, using notations very carefully, that is why the bar is not taken in the place of A, is complement. If you take alpha, then only it is better, and b and beta we have to write it carefully, right. So, AB minus alpha beta whole square is written as AB square plus alpha beta square minus 2AB into alpha beta. This is first bracket minus, what is the second one? A beta minus alpha b whole square. A beta whole square plus alpha b whole square minus 2 A beta into alpha b plus 2 into, what are the terms present? Alpha beta into AB minus A beta into alpha b. Okay. So, what are the terms which can be cancelled? A b square cannot be cancelled, therefore, it is written as it is. A b square plus alpha beta square is written as it is, minus 2 times A b into alpha beta can be cancelled with 2 times alpha beta into A b, right. And then minus of minus, this becomes plus, plus 2 times A beta into alpha b is cancelled with minus 2 times A beta into alpha b. So, you have left with only A b square plus alpha beta square minus A beta square minus alpha b square. Okay. Is this your right hand side which we have to prove, right? Check. A b square, we had started with left hand side, and the right hand side to be proved is A b square plus alpha beta square minus A beta square minus alpha b square. and then we arrived at this that which is equal to right hand side, hence proved. Okay. Now we will derive the second one. What is the second one we have to derive? Delta is equal to b into beta by n into ab by b minus a beta by b. Okay. Take the right hand side, b into beta by n into ab by b minus a beta by beta. Just multiply these things inside. You have ab into beta into b by n into b. b gets cancelled minus a beta into b into beta by n into beta. Beta gets cancelled and you have ab into beta by n minus a beta into b by n. Okay. Taking that ab into beta is written as n minus b, right, minus here instead of writing b we will write a beta. A beta is written as a minus ab. Okay. The whole thing by n. This is equal to now take that 1 by n outside, 1 by n, just multiply n into ab minus ab into b minus b into a plus b into ab. Okay. So, this b into ab and b into ab gets cancelled and you have only 1 by n into n ab minus b into a, or organizing it taking that n outside, n by n into ab minus a into b into a can be written as a into b by n, and this stands for ab minus ab naught, which is equal to delta, which is your left hand side, hence proved. Similarly, you can prove the same result with respect to a because of the symmetricity of a and b. Okay. Just by interchanging a and b and then alpha and beta using the symmetric property we can arrive at this delta. Okay. So, we finished with talking about independence of attributes. After independence of attributes, let us now talk about association of attributes. It is slightly just opposite to independent like. So, two attributes A and B are said to be associated if they are not independent but are related in some way or the other. So, they are said to be positively associated if you have delta is greater than 0. Delta greater than 0 implies AB is greater than A into B by n. Okay. And similarly, A and B are said to be negatively associated if delta is less than 0. Again using the delta formula, AB is less than A into B by n. Okay. In other words, the two attributes A and B are said to be positively associated if delta is greater than 0 and negatively associated if delta is less than 0. Yule's coefficient of association. As a measure of the intensity of association between A and B, Yule gave the coefficient of association Q defined as follows. That is AB into alpha beta minus A beta into alpha B divided by the numerator is with the negative sign of both the attributes, and the denominator the same thing repeated but with plus, okay, AB into alpha beta plus A beta into alpha B. And we have proved this thing stands for n delta in the previous slide. N delta is equal to AB into alpha beta minus A beta into alpha B. So, using that Yule's coefficient of association can also be written as n delta divided by AB into alpha beta plus A beta into alpha B. Okay. So, if A and B are independent, delta is equal to 0, delta being in the numerator of Q. Therefore, if delta is equal to 0 also implies Q is equal to 0. So, if A and B are independent, Yule's coefficient of association is 0. If A and B are completely associated, then either AB is equal to A is equal to AB is equal to 0, or AB is equal to B into alpha beta is equal to 0, or in each case Q is equal to plus 1. Next, if A and B are completely dissociated, then either AB is equal to 0 or alpha beta is equal to 0, and in this case you have Q is equal to minus 1. So, Q is taking the values of minus 1, 0 and then plus 1. So, Q ranges from the values from minus 1 to plus 1. Continuing with the Yule's coefficient of association, there is another coefficient called the coefficient of colligation, that is coefficient of associated with the coefficient of association itself. This is called coefficient of colligation, and it is represented as a capital Y, and this capital Y, which is called coefficient of colligation, has the same properties as Q, which is coefficient of association. So, Y is written as Y is equal to 1 minus root of A beta into alpha B divided by AB into alpha beta. The same thing with plus in the denominator, 1 plus root of A beta into alpha B divided by AB into alpha beta. So, Q is equal to 0 implies Q is equal to 0 implies Y is equal to 1 minus 1 divided by 1 plus 1, which is also equal to 0, because Q stands for A beta into alpha B minus AB into alpha beta, right? What is Q? Q is equal to Q is equal to 0 actually implies A beta into alpha B is equal to AB into alpha beta. Okay. Therefore, these two are equal, being root of 1. So, 1 minus 1 divided by 1 plus 1, Y is equal to 0, and similarly we have Q is equal to 1 implies Y is equal to 1, and conversely. A summary: in this session we have done an example in independence of attributes. Also, the association of attributes is discussed along with the coefficient of association and coefficient of colligation. In this session also we have discussed the notations AB naught and delta. We have derived an example in delta, and we derived a formula for delta also. So, based on this, these questions are frequently asked: what is meant by association of attributes? Give the formula for Yule's coefficient of association. Define coefficient of colligation. Thank you.